on TalkSport Extra Time in adding the extra into the programme by going around the world, literally. We can go to any continent, of course, by the magic of radio and telephonic communication, and unpicking, analysing some of those stories that make the papers, but have us scratching our heads. For example, this story I spotted, it was only last week in a couple of tabloids. The headline says, life forms created to clean up the seas and deliver drugs, and it says, scientists have created the world's first living robots from frog cells. Can it really be true? We're going to be speaking in a moment to Sam Kriegman, a PhD student from the University of Vermont. But first, here's how that story has been reported.
Imagine building a living organism from individual cells. Once this organism is built, it can move, be programmed, and do several assigned tasks, all without being controlled. After it runs out of food, it dies and is fully biodegradable. Now, imagine if this organism was designed by a computer algorithm. Well, all of this has just happened.
Well, this is happening at the University of Vermont. It sounds like an amazing breakthrough. I must confess my scientific knowledge means that my melon is more than slightly twisted by this story. So let's get an explanation now. Delighted to have the pleasure of his company as we welcome to TalkSport Extra Time, Sam Kriegman, PhD student on the team behind this project at the University of Vermont. Good morning, Sam, and welcome to TalkSport here in the UK.
Hey, good evening, Paul. It's a pleasure to be here.
Can you tell us, please, in kind of layman's terms, in simple terms, what's actually happening here? Is this some kind of micro-living robot? What's going on?
Yeah, that's exactly right. So we call these little guys Xenobots because they're made out of cells that come from very early embryos of the frog that's called Xenopus laevis. And we construct these cells into little tiny creatures or robots. They're about the size of a grain of salt. And the way in which they're put together was determined by a computer to perform a specific task. So these are 100% frog cells, but above the cellular level, they don't look like frogs. They don't look like animals. They're entirely new creatures that were designed to perform new jobs and hopefully someday useful work.
And what is the purpose of them? What are you hoping to achieve with these further down the line? What are they designed to do? Or what are their capabilities, I suppose, is a better question.
Yeah, well, at the moment, they don't do very much. They're extremely simple, and they don't look very impressive. They kind of just look like a popped kernel of popcorn. But they can walk, swim, they can push a small pellet around their dish,
right,
and they can work together with other little Xenobots to clean debris into neat little piles. So we can imagine future applications like gathering, instead of just debris in their dish, microplastics in the ocean, or deploying them inside of our bodies to scrape plaque from our arteries, or get rid of calcium deposits in arthritis in our knee joints, for example, and maybe further down the line doing some more crazy things like hunting down cancer cells.
And how are they controlled, Sam? I mean, I can't imagine there's some kind of remote control device for them.
Yeah, so they are controlled in the sense that they're designed. So they're made of, right now, just skin cells and heart cells.
Right.
And the way in which the skin and heart cells are positioned will make these little tiny creatures move in different ways. So if you place the heart cells in particular positions, it gives them little motors. The heart cells expand and contract like pistons.
Yeah.
And you can make them move in certain ways. And then there's a lot of stuff that we don't program, but we get kind of for free because they're made out of living tissues. They tend to just work together naturally when we place them together in a swarm. And they can heal themselves when they're cut almost in half.
Does that mean they self-generate? Can they create more of their own kind?
So there's no self-replication here. They're just skin and heart cells.
Right.
But they do heal themselves automatically, which is another reason why we would want to do this, because most machines are made out of metals and electronics, and when you cut them in half, they certainly don't heal themselves. So this is a potential advantage if we can get them to do more useful things than just kind of scoot around their dish.
And I'm presuming then you can almost use a scientific or robotic version of natural selection. The ones that perform best are then the ones you can you use those, maybe, I don't know, to clone more of these mini living robots?
That's exactly right. So that's exactly how the computer designs or programs these organisms. It runs a little kind of what's called an evolutionary algorithm inside the computer. So the computer puts together the cells in different kinds of arrangements, but it's all digital and virtual. There's no real ones moving around yet. And it simulates billions of designs, just design after design, making slight revisions and trying to pick out the ones that are best at, for example, pushing a pellet around the dish.
And how long do they live for? How long do they last, Sam?
Sure. So the real ones, once we build them according to this design, they live about a week. They're self-powered, so they come with fat and proteins. And once they burn that up, after about a week, they just disintegrate into dead skin cells.
Do you regard this in any way as humanity creating life for the first time? I mean, actually, almost kind of creating life from a test tube.
I definitely think these are living and that they're new living creatures.
Yeah.
I'm not sure that it's the first time that we've dabbled in this kind of thing, but it's definitely a new way in which we've done it. And I think it's really interesting, and it could have a lot of really useful applications like in medicine. So if we could understand really how to create and control living bodies, we could be able to control our own bodies and maybe, regenerate limbs after damage or reprogram cancer. So that's kind of like the dream of learning how to manipulate these things.
And finally, Sam, how long have you been working on this, and at what kind of stage are we at now? I mean, is there any way to give a kind of prediction or prognosis of the time before these things are being used, almost like that film Fantastic Voyage, to go into human bodies and zap cancer cells or something?
Yeah, exactly. I think that's a long way off. It's very basic research at this point. It's difficult to predict when or if Xenobots will actually be able to do something useful, but they're already becoming this really useful tool, not unlike a microscope or a telescope, and they let us kind of see things that are difficult to see with our naked eye, and they're helping us understand how cells can work together to build complex animals and us, and hopefully by understanding that, we'll see some applications in medicine eventually. But Sam, I think these are a long way off.
Absolutely fascinating, Sam. Thank you so much for your time this morning. This evening, your time. Sam Kriegman there, great guest. PhD student on the team at the University of Vermont, developing those, well, you heard it here, living robots. And that was this morning's special treat, something extra on Extra Time.